I'm doing number 90 for the extra credit assignment. It's from 5.6, and the question asks, repeat exercise 89 if the altitude of the plane is 3 miles and describe how the altitude affects the rate of change of theta. So you have to go back to number 89 and read the instructions. And part A asks to write theta as a function of x. And then part B, it says the speed of the plane is 400 miles per hour. Find d theta dt when x equals 10 and x equals 3. And so the picture will look something like this, but instead of it being 5 miles high, it's 3 miles high. And here is my picture. Yeah, I know my plane looks kind of weird, but oh well. So then what I did was I found the equation. So it was arc cotangent of x divided by 3 equals theta. And the way I got that was because I knew that I had to do something along the lines of finding theta. So I took the adjacent over opposite, which is cotangent, so it was arc cotangent of x over 3. So then, to find the rate of change, you have to take the derivative in respect to t. So I did that, and I took the derivative, and you have to use this base, negative u prime divided by 1 plus u squared. So I did that, and then I was left with negative 1/3 dx dt divided by 1 plus 1/3 x, and that's squared, equals d theta dt. So then I plugged in 10 and 3 to my equation. So when it's 10 miles, it's 11.009 radians per hour. And when it is 3 miles, it's 66.66 radians per hour. And the next part describes how altitude affects the rate of change of theta. And altitude affects the rate of change of theta by it changes the equation you use to find rate of change. Therefore, it affects rate of change. And in this equation, the rate of change was more instant. It was like there was a greater difference in the rate of changes in problem 90 than problem 89.